is a species...
Okay, question 2. Daphnia is a species of water flea that lives in fresh water. An investigation was carried out into the effect of water temperature on the heart rate of one Daphnia, sorry. Results are shown in the table. Okay, we've got our water temperature running from 2 degrees up to 22. Our heart rate is given in beats per minute for each of those water temperatures. Okay, calculate the average increase in heart rate per degree C between 2 degrees C and 22. Right, this is the per one. So although it says average, don't get drawn down that, add them all up and divide by the number you have. That is not what they're asking you for. What they're looking for is how much do you go up from 2 to 3 to 4 to 5 each time. Okay, so what we've got to do is take our difference here. Okay, so our difference going from 175 up to 219. Okay, so that is 44. So it's 44 degrees C, sorry, 44 change in heart rate between 2 degrees and 22 degrees. So it's 44 beats per minute change in 20 degrees C. So I just need that for 1 degree C, so 44 divided by 20 gives me 2.2. Okay? Right, Daphnia is a conformer. Use evidence from the table to confirm this statement. So conformers are altered by the external environment. They do not regulate regardless of the external. They change with the external. And what we have here is increasing water temperature here and an increase in the heart rate as you go. So there's nothing where it's stayed the same regardless of the external temperature. So it's almost a non-statement that you're trying to say here. Because they have not regulated, they must be a conformer. Okay, so because they have not managed to maintain a same heart rate regardless of external temperature, then they are conforming to the external temperature. Okay. C. Explain how an increased water temperature will result in a higher metabolic rate in Daphnia. Okay, so metabolic rate we can link to two things. So we can link to enzymes, and I think that's probably your go-to. It's your simplest one to go for. It's worth 2 marks, so we're going to have to say something about the enzymes and then why that does something, because it's explain. So if you said increasing water temperature means you've got a faster rate of enzyme action, or maybe you could say it's getting closer to optimum for the enzymes, and therefore you would have an increased metabolic rate for all things which are controlled by enzymes. Okay, the therefore is important. The other one to go for is actually what was also potentially in question 1. We could go for diffusion. Okay, if we are increasing the temperature, then we also should be increasing diffusion rates. So if we increase diffusion rates, because we can dissolve more and get a higher concentration, greater concentration gradient thing, if we've got an increased diffusion, then we could also have an increased supply of things like food, oxygen, anything that they need to do metabolism as well. So either of those, you either go down the enzymes route and then explain why that would impact, or diffusion and explain why that would impact. Okay. State the type of response shown by conformers to maintain an optimum metabolic rate. Conformers, it's behavioural. And that's it.